Hello guys, how are you today? So today I'll be explaining the physics AMS of term 2 week 5, okay? So I'm gonna not move too fast on this quiz because I have some points I want to cover first. I have some notes. I might do a recap at the end of the video for these notes, but the points I just need to go over first is that we have a couple of equations. Some of the equations, we can derive them from other equations. Now, throughout the video, we will see how can we derive. So just like a quick example, we know that power is equal to the current I times the voltage V. So if we don't have the current, but we are given the resistance, we can do that. The power is equal to, we know that the current I is equal to the voltage over the resistance. So it's equal to the voltage divided by the resistance times the voltage, or in other terms, voltage squared over the resistance. So these are just the points I wanted to cover. Now let us proceed. So just give me a second to find my calculator because I totally lost it. 1 second. Okay, it's here. So a straight cylindrical copper wire of length 1.5 meters. We are given our length in meters, okay? So we don't need to change anything. And cross-sectional area 1.3 times 10 to the power of negative 5 meters squared. It's also in meters squared, so we do not need to change anything. Has a resistivity, we are given resistivity. Okay, it's in meters, so good. There's nothing we need to change. There is no conversion factors that we are gonna apply here. What is the resistance of the copper wire? Very simply, what we need to know is that the resistance, denoted by R, is equal to the length of the copper divided by the area, which is the cross-sectional area, multiplied by the resistivity. So if we apply it here, that is gonna be R is equal to 1.5 divided by 1.3 times 10 to the power of minus 5 multiplied by 1.7 times 10 to the power of minus 8. So if you do it on your calculator, we are gonna get 1.96, so I'm gonna round it to approximately 2. So 2 times 10 to the power of negative 3. Okay, so to get rid of the power of negative 3, first of all, we know this is 2 times 10 to the power of negative 3 If you want to get rid of the negative 3, it becomes 2 times 10 to the power of negative 3 times 10 to the times 10 to the power of 3. So if you are multiplying by 10 to the power of 3, that means we are changing it into, we are changing it from into milliohm. So remember this conversion factor. If you want to change from milliohm to you divide by 10 to the power of 3. However, if you want to change from to milliohm, you multiply by 10 to the power of 3. So in this case, we are changing from to milliohm. So that means 2 times 10 to the power of minus 3 times 10 to the power of 3. We are gonna get then 2 milliohm. And our answer here is 2 milliohm. We move on to question number 2. They told us the ratio of the potential difference, which is the voltage. Ratio means divided. Across a conductor to the current, which means I, is equal to resistance. We know that the voltage or potential difference divided by the current, or I, is equal to the resistance of this conductor. Question number 3. They are looking for what? They are looking for the power consumed by this resistor. We know power is equal to the current times the voltage. We have what? We have the resistance and we have the voltage. We also know that the current I is equal to the voltage divided by the resistance. So what do I do if power is equal to the current times the voltage and I don't have the current, but instead I have the resistance? Very simply, we are going to substitute I by this equation over here. So now it becomes power is equal to the voltage divided by the resistance times the voltage. which in other terms is voltage squared divided by the resistance. So the voltage is 20, that means 20 squared divided by 5, and we are then gonna get 80 watts. So our answer over here is 80 watts. If you cannot memorize all of these equations, just memorize this basic equation, which is that power is equal to the current times the voltage, okay? And that the current is equal to the voltage divided by the resistance. So if they gave you, for example, in one question, the current and the resistance, and they need you to find the power, you can very simply substitute the voltage by what? By that the voltage is equal to R times I. From this equation, we moved R to the other side. We got voltage is equal to R times I. So memorize this equation and memorize this equation if you don't want to memorize a lot of equations, and very simply, if you are missing something, just substitute. Moving on to question number 4. Now, what is the electrical component X called? Electrical component X, this is usually referred to as a diode. So you see, I cannot draw it, a triangle on the line. This means it is a diode. So component X is called a diode. Now, how will the current flow in the circuit? Okay, very simply, we know that the current will flow from the positive side all the way to the negative side. So that means it will flow from A, then to C, then to B. So A to C to B. That means the current will flow from A to C to B. Moving on to question number 5, they need the electromotive force across this combination of cells. We know that we will take each two together, so 2 together, and then this is the first 2, and this over here is the last 2. If you cannot take two together, we can do them each one by themselves. So if we are starting with this one, it is gonna be the positive one, or the positive direction. So in this case, we have 1.5 because it's facing the positive direction, in addition to, again, it's facing the positive direction, so another 1.5. In addition to this one, again, it's facing the positive direction, so another 1.5. Whereas this one, it is facing the negative direction, that means it becomes negative 1.5. If you're wondering how I got 1.5, it's given up that each one has an electromotive force of 1.5. So if they are all facing in the same direction, they're all gonna be positive. If they are all facing in one direction except for one, that one is gonna be negative, like in this case. So what's gonna happen is we're gonna have 1.5 plus 1.5 plus 1.5 minus 1.5, so this and this becomes 0, so it becomes 1.5 plus 1.5, which is 3, plus 0, which gives us 3. So the total electromotive force is 3 volts. Moving on to question number 6. The potential difference across an ohmic conductor of resistance 50 ohms is 12 volts. The current through this conductor to 2 decimal places, they need the current. We know that the current I is equal to, the current I is equal to the voltage V divided by the resistance R. So we are looking for I. I is equal to the voltage, which is given as 12, divided by the resistance, which is given as 50. So 12 divided by 50 is gonna give us an answer of 0.24 amperes. So to 2 decimal places, it is 0.24 amperes. Question number 7, again we are following this rule, the resistivity rule, in where the resistivity multiplied by the length divided by the area is equal to the resistance. Okay? So the resistivity is given to us as 0.48 multiplied by the length is in millimeters. To change it from millimeters to meters, we multiply by 10 to the minus 3, or we divide by 10 to the power of 3. Multiplying by 10 to the power of negative 3 and dividing by 10 to the power of 3 is the same exact thing. So from millimeter to meter times 10 to the power of minus 3, it is gonna give you, let me just do it on my calculator. It is gonna give you 5 times 10 to the negative 3. I don't know why I needed the calculator, but anyways. For this one, okay, it is millimeter squared. So whatever we are doing to the millimeter, we are squaring it. That means we are gonna square this one. So it's gonna be 10 to the power of negative 6. So that means we are gonna be multiplying it by 10 to the power of negative 6. Okay, and this will result in us getting 1 times 10 to the power of negative 6. If you didn't understand how I did it, we know from millimeter to meter is times 10 to the power of negative 3. Now we are given millimeter squared. We need to change it to meter squared. We squared everything. Logically, we also need to square this. So it's gonna be 10 to the power of minus 3 to the power of 2, which is 10 to the power of minus 6. Now we are given everything. We have the resistivity, which is 0.48, times the length, which is 5 times 10 to the power of negative 3, divided by the area, which is 1, times 10 to the power of negative 6. So doing it on the calculator, 0.48 times 5 times 10 to the power of minus 3, divided by 1 times 10 to the power of negative 6, we are gonna get an answer of 2400 ohm, but they need it in kilo ohm. So to change it to kilo ohm, we are dividing by 1000, and like that we are gonna get 2.4 as our answer. Moving on to question number 8. We have the current I flows in a 20 ohm, this is the resistor R, for 1.5 minutes. This is the time in minutes, so we will change it to seconds by doing 1.5 times 60 seconds, which is then 90 seconds. Now, they need the amount of energy dissipated. Energy dissipated means energy lost or heat lost in this resistor. The equation for this is W. W is equal to the current times the voltage times the time in seconds. Are we given the voltage? No, we do not have the voltage, but we know that the voltage is equal to the resistance times the current. So very simply, we can find the voltage. Our resistance is 20 ohm and our current is 3, so that becomes 20 times 3, which then gives us 60. So W is equal to the current I, which is 3, times our voltage, 60 volts, times our time, which is 90 seconds. So 3 times 60 times 90, we are gonna get 16,200. So let us check our answer. They are in kilojoule, so 16,200 joule, approximately 16 kilojoule. So our answer is 16 kilojoule. Moving on to question number 9. Here we need to memorize the tables. Okay, I'll just write the tables above as a brief summary. We have table like this. If it's a straight line passing through the origin, then it is an ohmic conductor. So ohmic conductor. Okay. If it is passing somewhat like this, then it is a thermistor. If it is passing like this, then it is a filament lamp. Alright? And if it is passing like this, then, or not like this, my bad. If it is passing like this, then it is a semi-conducting diode. These are the graphs you need to memorize. So for the first one, by looking at it, it's a semi-conducting diode. The second one is a straight line passing through the origin, so it's an ohmic conductor. Moving on to question number 10. A potentiometer is connected in series with a 6 voltage power source. As shown below, the slider of the potentiometer can be placed anywhere between points X, Z, and Y. They told us point Y is the center of the potentiometer. So, very simply, they said, where should we place the slider in order to give a 0 output voltage? Now, if you think about it, if you put the slider of the potentiometer, which resists the voltage, okay, if you put it on X, it is gonna resist the full voltage that's passing, all right? However, if you put it on Y, and they said Y is at the center, or in other terms, midpoint of the potentiometer, you are gonna be cutting it in half, so it's gonna only allow 3 volts to pass. Whereas, if you put it at X, it's gonna allow 6 volts to pass. Or it's gonna resist 6 volts. And if you put it at Y, it's gonna resist 3 volts. Whereas if you put it at Z, so because Z is inside of the line and outside of the potentiometer, then it is gonna resist 0 volts. So they told us, where should we put in order to give us a 0 output voltage? Definitely, we will put it over here. Then 0 volts will be able to pass through it because it's a resistor. 0 volts are going to be able to pass through it. And if we put it at Y, only 3 volts will be able to pass through it because it's exactly in the midpoint. And if we put it at X, 6 volts will be able to pass through it because it is outside, or it is the maximum range of the potentiometer. So 0 output voltage is Z, okay? 3, if they're asking for 3 voltage, then we are going to Y. And then if they are asking for maximum output voltage, then we will put X. So the answer in order is Z, X, and Y. Moving on to question number 11. They need us to find the equivalent resistance, but they are put in parallel. When they are put in parallel, very simply, to find the resistance equivalent, or REQ, which is the resistance equivalent, it is usually equal in series. Before we find this, we need to flip it, so it becomes 1 over the equivalent resistance is equal to 1 over resistor 1 plus 1 over resistor 2, blah blah blah, etc. As many resistors as you have. But there is a special case. If and only if you have 2 resistors, okay, you can use this method. So in this case, we have 2 resistors that are connected in parallel. So you use this only if they are connected in parallel, and only if they are 2 resistors. So what we are going to do is we're going to put 30 and we are going to multiply it by 70. So resistor 1 times resistor 2 divided by resistor 1 plus resistor 2. So if you try both ways, if you try this way, for example, 30 times 70 divided by 30 plus 70, you are going to get 21. But if you tried the opposite way, so you flip them and then you flip it again, so 1 over R equivalent is equal to 1 over 30 plus 1 over 70. If you did it on the calculator, 1 over 30 plus 1 over 70, you are going to get then 1 over 21. So you have to flip it again and it becomes 21. So the equivalent resistance of this group of resistors is 21 ohms. Moving on to question number 12, these are in series, so whenever we have resistors in series, then R equivalent is equal to R1 plus R2 plus R3 and etc. So the equivalent resistance of this group is 15 plus 20 plus 50, which is all in all equal to 85. Moving on to question number 13. This question is really nice, but it is a bit difficult. So let us explain. A 1.5 ammeter can measure currents up to 200 milliamperes. Let us change this to amperes. This becomes 0.2 amperes. In order for the ammeter to measure, okay, first of all, ammeter, whenever it is used to measure the current, it's placed in series. Okay, so definitely if we are putting a shunt resistor, it has to be in the opposite manner. So that means the shunt resistor will be put in parallel. So over here, our answer is parallel. Now, to find the resistance of the shunt resistor, we have to follow a really long equation. Okay, so the equation is that, sorry if the time keeps on going, this is not on your time, this is on my time. So the equation is that the full scale current multiplied by the resistance of the ammeter, or I will say resistance C, is equal to the total current minus the full scale current, okay, times the resistance of the shunt. So in this case, the full scale current is 0.2 amperes, okay, multiplied by the resistance of the ammeter, which is 1.5, is usually equal to the total current, which is given here, 10, minus the full scale current, which is 0.2 amperes. So 10 minus 0.2 gives us 9.8 times the resistance of the shunt. So now, making it an equation, 0.2 times 1.5 is 0.3. 0.3 is equal to 9.8 times R. So the resistance of the shunt is equal to 0.3 divided by 9.8, which is approximately 0.03. Okay? But notice how they don't want it in ohm, they want it in milliohm. So this is in ohm. To change it from ohm to milliohm, we multiply by 10 to the power of 3, and we are gonna get 30.6. I forgot when I rounded here the 6. So please on your calculator, keep it as it was 0.0306. So when you times 10 to the power of 3, it becomes 30.6. So over here, our answer is parallel, and over here it is 30.6. Okay, so moving on to question number 14. In the diagram below, the potential difference across the battery is 24 volts. Resistance of each resistors A and B is 10. Okay. And they need the resistor, and sorry, we are given resistor C. They asked us then the current through resistor C. They need us to find the current through resistor C. So what we can do here is we can create a collective total resistor. What does it mean? We have A and B, they are parallel. We can make them into one resistor. First, let us make them into one resistor. So we will do 1 over R equivalent is equal to 1 over 10 plus 1 over 10, which is on the calculator 1 over 5. So then we flip it again. That means equivalent resistance over here is 5. Okay, so let me draw a new diagram. This over here is 5 ohm, and this over here is 45 ohm. To find the equivalent resistance, because they are in series, we can add them. So 5 plus 45 is 50 ohm. So now we have the resistance, the total resistance. And now to find the current I passing through C, we know that the current is the same through parallel. So the current I passing through C is the voltage, 24, divided by the total resistance, which is 50. So 24 divided by 50 is then 0.48. And this over here is the current. Moving on to part B, the current through resistor A to 2 decimal places is. Now, very simply, we know that the current in series is the same, whereas in parallel, it splits, okay? So that means the current is gonna split here and here. You can do this in 2 ways. First way, because A and B are equivalent resistance, it will divide equally. So this will become 0.24 and this will become 0.24. Or in another way, you can take the voltage, okay, and we know that the voltage is always the same when it is in parallel. So here's 24 volts and here's also 24 volts. We take the total resistance, or the equivalent resistance, which in this case was 5. Then we take the current that we got before, which is 0.48, and then we multiply it by 5 to get the voltage, okay, which is then 2.4. Then we take 2.4, for example, and then we divide it by the current in A, which is then 10, and we are going to get 0.24. So that is how we get 0.24. Question number 15. Give the expression that relates the current I passing through a conductor, the potential difference across it, V, and its resistance R. So here you can write it in whatever way you want. You can write that R is equal to V over I, or V is equal to R times I, or I is equal to R over V. Whichever way you want to write it, you can write it. So simply I'm going to write V is equal to Ri, no, not necessarily to put the times. Just a simple V equals Ri is correct, or I equals V over R, or R equals V over I. Moving on to question number 16. Here we have the graph of an ohmic conductor. An ohmic conductor is something that is a conductor that obeys Ohm's law, which is that V is equal to R times I. Okay, they need the resistance. We know that the resistance is what? Is the voltage divided by the current. In other terms, if we are talking graphically, resistance is equal to the slope. So take just any point because it's a straight line passing through the origin. For example, this point over here, you have the voltage is 20 divided by the current, which is 0.5. You are then going to get a value of 20 divided by 0.5, which is 40. So the resistance is 40 ohms. Moving on to question number 17. Here we just need to label the figure. Okay, so very simply, usually the big, I don't know what to call it, the big device, okay, that's very long, it is usually a potentiometer. This is how we write it. Then if we have a smaller version of like a smaller block, okay, then this is a simple resistor. Now this over here is very simple. It's the voltmeter, and then this over here is the ammeter. Moving on to question number 18. Now, which law is used to determine the equivalent resistance of resistors grouped in series? This is very simply Kirchhoff's second law. So Kirchhoff's second law is about resistors being grouped in series, whereas his first law is that the total current entering a junction is equal to the total current leaving a junction. So if you have 5 volts here, this is your junction. You will have 2 over here, so 3 volts and 2 volts. This is his first law, whereas his second law is about that resistance in resistors being in series. You just add them to find the equivalent resistance. Moving on to question number 19. We need to find the equivalent resistance of these 3 resistors. Since they are in series, we just add them. So 4 plus 5 plus 6, which is then 15 ohms. Moving on to question number 20. A small electric bulb of resistance 40 ohm is connected to a power supply of 5 volts. They need the current passing through the bulb. So 5 volts, this is the V. 40 ohm, this is the resistance. We need to find the current I. So very simply, the current is equal to the voltage divided by the resistance. So 5 divided by 40, which is then on the calculator 0.125. But this is in what? In amperes. They need it in milliamperes. So to change from amperes to milliamperes, we multiply by 10 to the power of 3. So that's going to be 0.125 times 10 to the power of 3, which is then 125 amperes. So our answer for this one is 125. Moving on to question number 21. Here we have an electric fan shown below is connected to a socket providing 230 volts. This is our V. On average, the fan has a current of 0.3 amperes. This is our current I. How much power in watts is consumed by the device? Very simply, power is equal to the I times V. Our I was 0.3 times our voltage, which is then 230 if I am not mistaken. So that makes it 0.3 times 230, which is then 69. So our answer for here is 69. Question number 22. Here you just have to imagine it. If they are all grouped in parallel, we know that electric cells grouped in parallel, they will all give us one electromotive force, which is the initial one, which is 1.5. Okay? Now, if you put them in a series, then they are going to become additive. So you're putting the cells in parallel, it's all going to be the same. Okay? If you are putting them in series, they are going to be additive. So they are 3 cells, so it's 1, 2, 3. So 1.5 plus 1.5 plus 1.5, which is then 4.5. Now, 2 cells in opposition to the third one. So let us say this one, and then this one, and then finally we have this one over here. So this over here is 1.5, this is minus 1.5, and this is plus 1.5. This and this become 0, so 0 plus 1.5 will just give us an answer of 1.5. Moving on to question number 23. Again, anything that obeys Ohm's law is called what? It is called an ohmic conductor. So let us see, does this follow Ohm's law or not? Let us very simply find the resistance R. Before that, we will change from milliamperes to amperes. So to change from milliamperes to amperes, we divide by 10 to the power of 3 or times 10 to the power of minus 3. So it becomes 20 divided by 10 to the power of 3, which is 0.02, then 0.04, and then 0.05. Now to find the resistance, we know resistance is equal to the voltage divided by the current. So 12 divided by 0.02, 600, then 24 divided by 0.04, also 600, and then finally the potential difference, which is, the last one, which is 30 divided by 0.05, which is also 600. So they all have the same resistance. That means they are ohmic conductors because they apply to, or they follow Ohm's law. So this is an ohmic conductor. We found the resistance, which is 600 ohms. Now we need to find the resistivity. Okay, usually they tell us to find the resistance. Resistance is equal to resistivity times length over area. Now they're asking for resistivity, so we will have to move this to the other side. So resistance divided by length over area is equal to resistivity, or in other terms, resistance times area over length is equal to resistivity. So we are given the resistor's length. We will change it to meters, so it is 40 divided by 100, which is 0.4. Then this one, we will change it to meters, so it will become 0.2 times 10 to the power of minus 6. And then we have the resistance over here, which is 600 ohm. So to find it, it's going to be 600, the resistance, times the area, the cross-sectional area, 0.2 times 10 to the power of minus 6, divided by the resistor's length, which is 0.4. So we get an answer of 3 times 10 to the power of minus 4 ohm per meter. 10 to the power of minus 4 is already put, so we just need to put 3. Moving on to question number 24. We have the current I, which is 2 amperes, and then a resistor 50 ohms Okay, the potential difference V, they need to find it. It is very simply voltage is equal to R times I. So the R is 50 ohm multiplied by the current I, which is 2. We will get 100 volts. So the answer over here is 100 volts. The amount of heat liberated in this conductor in 3 minutes, we know amount of heat, or W, energy, work, is equal to the current I times the voltage V times the time T in seconds. So W is equal to the I 2 times the V 100 times the time. So we will change 3 minutes into seconds, so 3 times 60, which is 180 seconds. So 2 times 100 times 180, that is 36,000. So change it into kilojoules, because this is in joules, it becomes 36 kilojoules. Moving on to question number 25. The circuit shown in diagram A is used to control the current. How do you know? Because look, pay attention. If it is smaller, then this is a rheostat, okay, and the rheostat will measure or resist the current. If it's bigger, then it's a potentiometer, okay, then this one is used to measure the voltage or to resist the voltage. So the first one, in A, it's smaller, it's used to control the current, and in B, it is used to control the potential difference or the voltage because it is bigger. Moving on to question number 26. If you remember the graphs that we drew before, okay, I will draw them again. We have the first graph, which is a straight line passing through the origin. This is for ohmic conductors. We have a second graph, which is like this. This is for the thermistor. The third graph, which is like this. This one is for the filament lamp. And then the final graph, which is for semiconductors, it is like this. So looking at the graph, it looks a lot like the filament lamp or the filament bulb graph, okay? And they said for low currents, the resistance of the circuit element is. Very simply, low currents means when it is behaving like a resistor, okay? So in the filament lamps, the resistor is so weak. That's why it needs really low currents for it to properly behave like a resistor or to follow the Ohm's law. So for it to properly work, it needs low current. So they said for low current, so let's take anything random. So at 0.2, we have 10. So the voltage, which is 10, divided by the current, which is 0.2, will give us an answer of 50. So for low currents, the resistance is then 50 ohms. Moving on to question number 27. A voltmeter measures a maximum voltage of 10 volts. Its resistance is 2 kilo ohms. A shunt resistance is used to modify its scale so that the voltmeter can read a maximum voltage of 50 volts. Now, the shunt resistor would be connected in series because remember, the shunt resistor is always connected in opposition. So the voltmeter is connected in parallel, shunt resistor is connected in series. Ammeter is connected in series, shunt resistor is connected in parallel. Okay, they need us to find the resistance of the shunt resistor. So to find this, it is a bit complicated. Very simply, we need to find the current, I. To find the current I, we're not going to be using the maximum voltage. We are going to be using the, not the new maximum voltage. We're going to be using the old maximum voltage. So very simply, it is 10 volts divided by the resistance, which is 2000 ohm, will give us 0.005 ampere. This is our current I. Okay, so now we need to calculate the new resistance. The new resistance is very simply, to calculate it, we take the new voltage, which is 50, divided by the current, which is 0.005. So on the calculator, 50 divided by 0.005, is 10 1000 ohm. So this is our new resistance. Now, to find the resistance of the shunt resistor, it's very simply the new resistance, which is 10,000 ohm, minus the old resistance, which is 2000 ohm. So that gives us an answer of 8,000 ohm, which in kilo ohm is 8 kilo ohm. Now moving on to the final question. Now finally, question number 28. Consider the circuit shown in the diagram below. The bulbs in the circuit are identical. Okay, the brightness of bulb 1 versus the brightness of bulb 2. Here, when we are talking about the brightness, we are talking about the current. So if you notice, bulb 1 and bulb 2 are in parallel. And we know when they are in parallel, then the current is definitely gonna be different. But we know that bulb 1 is in parallel with bulb 2 and bulb 3 and 4. So that means the current that will come from here will pass exactly the same through bulb 1. So the same in bulb 1, because so far it's not in parallel with the battery. It's actually in series with the battery. So it's going to pass the same. Whereas bulb 2 is in parallel with the battery. So it's going to be different. And then bulb 3 and 4, since they are also parallel with the battery, it's going to be different. So that's why, since bulb 1 is in series with the battery, it is going to have a greater current, which means a greater brightness than bulb 2. Now the brightness of bulb 3 and 4, since they are in series, okay, they're both going to receive the same current, so it's going to be equal brightness. And then finally, no current will flow in the circuit if bulb is removed. So the whole purpose of the current is that it will continue from the positive side to the negative side, no matter which path you choose. So if you remove 2, it's gonna go like this and reach the negative side. You remove 3 and 4, it's gonna go like this. No, sorry, it's gonna go like this and reach the negative side. However, if you remove 1, it's gonna stop here and it's an open circuit. So the only bulb that you remove and it will cause the circuit to completely not work is bulb 1. So that is it. We will submit. Hopefully there are no mistakes. Okay, so I believe this question is wrong, okay, because this is supposed to be a filament bulb. So let me just search it up 1 second. So if you notice, this is what the filament lamp IV graph looks like, okay, and I opened the answers, my bad, I opened the answers, it said the answer is thermistor, so definitely this in the quiz is wrong. So wrong in quiz. This graph is meant for the filament lamp graph because this is what it looks like. Whereas a thermistor IV graph looks like this. So they are mistaken and I am correct. So I'm just gonna keep it like this. And I had to, it's okay. I'm just gonna keep it like this as a filament bulb because they are mistaken for sure. So thank you guys for watching. Please pay attention to this mistake that is in the quiz and have a wonderful day.